Hello, and this video is going to be on how to move between what we call scientific notation and standard notation. So an important thing to understand is that this number right here, 700,000, is written in what we call standard notation. Standard notation is just the normal, regular way that we write numbers. Scientific notation is a more efficient way of writing really, really large numbers or really, really small numbers. And we're going to talk about how to turn this number, 700,000, into transform it into scientific notation form instead of standard form. And so the way we're going to go about that is we are going to have a decimal right here, and we want the end goal here for the decimal to be having only one whole number in front of it that is not 0. And so to do that, I've got to move 1, 2, 3, 4, 5 spots to the left. And all we're doing in scientific notation is counting how many places we need to move the decimal to get only one number that is not 0 in front of the decimal. And so what we're ending up with here is we've got 7 is what would be in front of the decimal. And then scientific notation goes like this, times 10, and then to the number of places that we had to move the decimal. So in this case, 5. So it's important to understand that we're not changing anything. These two things are equivalent. 7 times 10 to the 5th is equal to 700,000. Just a different way of writing that same number. That's going from scientific notation to standard form. Number 2 goes from standard form to scientific notation to standard form. And so we can see that our exponent here is 3, and it's positive. So a positive exponent means that we're going to be moving the decimal to the right. And so we can see that we had 8 times 10 to the 3rd. And so what that means is we take our decimal place, and it's 10 to the 3rd, so that's a movement of 3 spaces. So 1, 2, 3. Our decimal ends up right there. We fill the empty holes with zeros. So that number is going to end up being 8,000. And similar to number 1, we can see that 8,000 is equal to or equivalent to 8 times 10 to the 3rd. Those are the same number, they have the same meaning, it's just two different ways of writing the same number. So in this case, this would be the answer here. Because we were asked to write it in standard form, this would be the answer here, because we were asked to write that first one in scientific notation. So, on to number 3. Exactly the same as number 1 and number 2, except that this time we have a couple numbers after the decimal. That does not change anything. We're just looking at how many places our decimal needs to move. In this case, it's positive, so that's a movement to the right. So we start with what we are given, 5.52, and we need to move that decimal 5 places to the right. So 1, 2, 3, 4, 5. Our decimal ends up right there. We fill the empty slots with zeros. And so that number ends up being 552,000. And as we discussed with number 1 and number 2, that is equivalent to, it's the exact same thing as what we started with, 5.52 times 10 to the 5th. On to number 4. We're going from standard form to scientific notation. So we place our decimal initially, and we have to move to the left to get the decimal to only have one number in front of the decimal. So there's 1, 2, 3. So we end up with 7.553. We moved our decimal 3 spots, and so that's going to be times 10 to the power of 3. Now, one thing you may have noticed, or may not have noticed up until this point, is that all of these exponents that are attached to the 10, in the first case, the 5, the second case, the 3, in the third case, the 5, and the last one also a 3, is that these exponents have all been positive. And the reason they've all been positive is because these numbers are all larger than 1. And so when we have a number that is larger than 1, in scientific notation, our exponent is always going to be positive. Moving on to number 5, we see that we have an exponent that is negative. Now, negative means that the number is going to be smaller than 1. It's not a negative number. It's a number that has a value that is less than 1. And that might be a little bit of a point of confusion, so we'll talk through this and try to make sense of this. So this -5 here, you'll notice in these examples up here when it was positive, we moved to the right. It's negative, so that's going to tell us to move to the left. And so we start with what we're given. We have a 9 with a decimal after it. And our exponent is -5, so to the left 5. 1, 2, 3, 4, 5. And again, we go to the left because that exponent is negative. We fill the slots with zeros. So that number becomes 0. I like to put a 0 in front of a decimal. 0.0009. That's going to be that number written in standard form. And with number 6, we have something similar, a negative exponent. So moving to the left with the decimal. So we have a 3 with the decimal right there. The exponent here is -2. So -1, -2. We end up with 0.03. Again, as I mentioned, I like to put a 0 in front of the decimal. So 0.03 is going to be equivalent to the 3 times 10 to the power of -2. Now for number 7, remembering this number is less than 1, so we are going to have a negative exponent. And we only want one number in front of the decimal that is not 0. So moving it 1, 2, 3, 4 spots, we get 7.35, and we moved that 4 spots, times 10 to the 4th. But remember that this number is less than 1, so that's going to be 10 to the -4. And so again, if we have a number that is larger than 1, we have a positive exponent. If we have a number that is less than 1, we have a negative exponent. Moving on to number 8. So for number 8, we have that number times 10 to the power of -2. So we are moving to the left. This number is going to be less than 1. So 3.254. We're going to take that decimal and go 2 places to the left. 1, 2. And we end up with 0.03254 as our final answer for that one, written in standard form. Okay, and number 9 and 10, application problems in this case, but still just scientific notation. So the diameter of Neptune at its equator is approximately 4.95 times 10 to the 4th kilometers. Write this number in standard notation. So all we're doing is converting. We have 4.95 times 10 to the 4th. This number is larger than 1, so moving the decimal to the right. 1, 2, 3, 4 spots. We put zeros in the empty spots, and we end up with 49,500. And then part B, we have an astronomer's infrared telescope is able to detect radiation with a wavelength of whatever that number is, meters. Write this number in scientific notation. So we're going to move the decimal to the right 1, 2, 3, 4, 5 spots to have only one number that is not 0 in front of it. So we get 3.81 times 10 to the 5th, and that is a -5 because that number is less than 1. And lastly, the total surface of South America, is approximately 6,890,000 square miles. We're asked to write that in scientific notation. So starting with our decimal here, we need to go to the left 1, 2, 3, 4, 5, 6 spots to only have one number in front of the decimal that is not 0. And so we get 6.89. times 10, we move 6 spots, so to the power of 6. And that is a positive 6 because this number is much larger than 1. And lastly, signal from a satellite is 1.3 times 10 to the negative 2 seconds to reach Earth. Write this in standard notation. So we have a exponent of negative 2. So our 1.3, the decimal is going to move to the left 2 spots. 1, 2. And we end up with, I want to put a 0 in front of the decimal, so 0.013 is what that number ends up being in standard form. So in ALEKS, you should have a written homework assignment that is the same construct as this stuff. You're probably going to get different problems than I did, but I hope that this is helpful, and I hope you have a great day.